Here we're being asked to solve a radical equation. The first step for doing that is to isolate the radical. To do that here, I'm going to subtract 3x from both sides. I'll have negative square root of 3x plus 7 is equal to negative 3x minus 5. And if I divide everything by a negative, I'll end up with the square root of 3x plus 7 is equal to positive 3x plus 5. Once you've isolated the radical, the next big step is to undo it. To undo the radical, you want to square both sides. So I would recommend that you put each side in its own grouping and then square it. On the left-hand side, the square is going to undo the square root. We'll be left with 3x plus 7. On the right-hand side, if I were to take the time to FOIL that out, I'll end up with 9x squared plus 30x plus 25. And once I've gotten rid of the radicals, I can just solve the equation like I always would. Looking at this equation, it's quadratic, so I want to set everything equal to 0. I'll subtract 3x and subtract 7 from both sides. So give me 0 is equal to, I'll have 9x squared, and 30x minus 3x is 27x. And then I've got 25 minus 7 from both sides. 25 minus 7 is 18. And I see something else that's going to make solving this a little bit easier for me. All of my coefficients on the right are divisible by 9. So if I divide everything by 9, I'll end up with x squared plus 3x plus 2 is equal to 0. So this equation I can solve pretty easily by factoring instead of using the quadratic formula. This factors to x plus 2 times x plus 1 is equal to 0. And then I know that if I set each factor equal to 0, I'll have x is equal to negative 2 or x is equal to negative 1. It feels like I'm done, but I have to be really careful because this was a radical equation. I have to make sure that both of these answers actually work in my equation. When I squared both sides here, it's possible that I introduced what are called extraneous roots. So I'm going to substitute those values back in and see if they work out. So if I plug in x is equal to negative 2, I'll have 3 times negative 2 minus square root 3 times negative 2 plus 7 is equal to negative 5. 3 times negative 2 is negative 6 minus the square root of 3 times negative 2 is negative 6. Negative 6 plus 7 is 1. This has to be equal to negative 5. And then negative 6 minus the square root of 1 is 1. And I end up with negative 7 is equal to negative 5. So x equals negative 2 is not a solution. I still need to check x equals negative 1. That one might not be a real solution either. So same story, 3 times negative 1 minus square root 3 times negative 1 plus 7 is equal to negative 5. 3 times negative 1 is negative 3. Subtract inside the radical. 3 times negative 1 is negative 3. Negative 3 plus 7 is 4. And then negative 3 minus the square root of 4 is 2. And I end up with negative 5 is equal to negative 5. So x equals negative 1 is my solution.